Hello, everyone. Welcome to the workshop with Emily from Truffle. She'll be speaking to you today about how to write ERC 4907 contracts, how to rent land in the metaverse. It's a very exciting topic today, so I hope you're all ready. We're really excited for you all to be here. Just a few reminders. If you haven't joined the Discord channel for the Metaverse Hackathon, please do. Just a reminder, once you've joined the server, you do need to click hack access and then click the little Milky Way emoticon or emoji to get access into the Metaverse channel. If you have any questions, please feel free to ping me. I'll be answering any questions in the chat box. And if you've got any questions for Emily, please save them all for the end and we'll go through them at the end. So yeah, Emily, welcome to the Metaverse Hackathon. Thank you so much for being here, and I'll hand over to you.
Okay, cool. Hello, guys. Good. It's like afternoonish for me. I don't know. Everyone's all over the place, so I'll just say hello instead of good morning, good night, good afternoon. As Alex said, I am the Truffle Developer Advocate, and today we're going to go over the ERC 4907 smart contract. So I'm going to go ahead and share my screen. Okay, so today we're going to talk about the ERC 4907 smart contract, not necessarily renting land in the metaverse, but that is one of the use cases that you could potentially use it with. So touching on the agenda for today, I'm going to sorry, I'm like trying to hide this thing, but I don't know how to do that. Okay, whatever. So going over the agenda today, we're going to go over what exactly is a 4907, what's inside of it, actually step through an example of how to implement the 4907. And since this is a hackathon, I wanted to give you guys some like developer tips and tricks for making that experience a little smoother. And as Alex said, leave some time for Q&A at the end. So what is a ERC 4907? So basically the ERC 4907 is the latest ERC standard. So specifically, it sets up a set of rules that define rentability. So I don't know what level of expertise you guys are at, but just to take a step back first and explain what an ERC is, you can kind of think it as an interface, right? A set of rules that if this is implemented, anyone can understand how to interact with this smart contract. That's like what powers interoperability, for example. So in the ERC 4907, the specific rules that we care about are super simple. First off, it separates out the concept of user from owner. So owner is probably what you guys are used to with NFTs. That's just the owner of the NFT. Now we have this idea of the user, and that's going to be the renter, like the person who has the permissions to actually start doing whatever the owner is allowing them to do with that NFT. The second piece of it that defines rentability is essentially just an expires function. So that's just a property on the smart contract that tells you when that usage is going to end, and it's represented as a Unix timestamp. I do want to note, this is actually really interesting. ERC 4907, the most common use case and most logical use case that people think about it as is an NFT, right? So renting land in the metaverse, gaming, other things. But if you notice in the definition, nowhere does it say it has to be a 721, right? So actually, you could also reword this to be the universal rentable standard. I don't know exactly a strong use case for maybe making like a token rentable, but you might think, oh, maybe an 1155, if you guys are familiar, which is both like a token and NFT contract, might be a good candidate for the 4907. Or, I mean, if you guys are working in the hackathon, you find some wild new use case. But I did want to just highlight this is the universal rental standard. So do not feel, I guess, forced at all to use this as an NFT. So actually, it's super simple. I mean, we're just about to jump into implementing one. I'm gonna do all of this live. Hopefully everything works. I did want to call out, as I code, I want to call out a few caveats. I wrote this tutorial maybe like last month, 2 months ago. There are two things. So I have a guide online if you guys want to follow afterwards. But there are two, I guess, little nuances that are changed because Open Zeppelin has modified its contracts. So I'll go ahead and touch upon that during this demo and then update the guide afterwards. So first setup wise, I am the Truffle developer advocate. So today we will be using Truffle. So typical, I guess, smart contract development lifecycle. You'll need a blockchain development environment. That could be Truffle, Hard Hat Foundry, whatever you guys are using. Infura to connect to a test net or a mainnet, so your JSON RPC. To test it locally, we use Ganache in the Truffle test suite. Today, I'm going to actually be doing this entire process primarily through our VS Code extension. So Truffle kind of has two ways for you to create your projects. You can either do it completely through the UI. Alternatively, you also have that CLI experience. So that's a little bit where Truffle is going in terms of dev UX for beginner developers. But anyways, that's, I think, everything we need. Oh, I mean, the second piece, test ETH. That's going to be also, you need a MetaMask wallet. I know girly faucets are pretty dry and people are thirsting for it. So with Ganache, you can also do forking, copy a girly instance, mainnet instance of Ganache locally. So you can ignore that whole test ETH experience. I'm not sure if the hackathon has any requirements that you have to deploy to an actual testnet, but at least for iterating, I do highly recommend just sticking with local development first. So let's get started. I'm going to open up VS Code, like as I said, I guess you could start the whole process through here. If you download it, I just did a Command-Shift-P. It'll bring up a new Solidity project. You have three options here, a Truffle init. So that's just a blank project, a sample project with some stuff, and then Truffle Boxes, which I will touch upon later. But we're just going to do a really simple empty project. So I'm going to create this guy right here, create a new folder. Let's call this 4907 demo. Create and select a new project path. And I think it should have just created all of that's the Truffle init. So had you not wanted to use the, I guess, extension, you could just do like a Truffle init and then like folder name or something like that. So that's definitely not required. But yeah, just to explain kind of first off the structure of this. So contracts is where our contracts are going to go. Our second piece is migration. So that's how you tell Truffle the dependencies and order you want your contracts to be deployed. Obviously, test-driven development is really important. I think my understanding of Enco Club is actually you guys do a really good job of test-driven development as compared to like other, I guess, tutorials. I'm not sure if that's true, but that's what I heard. And so, I mean, really great things. So anyways, to start off, basically to create our implement the 4907, we're going to have three contracts. So that's going to be called ERC 4907, Truffle contract ERC 4907, and then the last piece is create contract, and I just call it rentable pets. There's I guess, underlying reason for why I make everything pets themes, but that's like my personal preference. You can name this whatever you want. But that's going to be what you would we would call our NFT collection. And the last piece, of course, is going to be our create test. So obviously you can just create these files on your own, but I just did them through the command line because it's easier. And then, I mentioned one last thing. Truffle config is just going to be, I guess, the configurations for Truffle. So telling it what networks you want to deploy to, like your testing configuration, Solidity versions, etc. So let's get to the part where you guys are probably excited to learn about is actually implementing it. So if you haven't actually implemented an ERC before, it's super simple, right? all you need to do is follow the specifications from the Ethereum proposal. So if you go to the Ethereum proposal website, you can basically see, the whole motivations behind it, whatever. But the most important part when implementing is actually following the specifications. So these are the rules that any dApp in the ecosystem will understand from it. So just to step over kind of what is in this interface, update user. So the rule here is anytime something is updated, you do need to emit this event. Same with setting the user. So this is how you tell, I guess, anyone who wants to set the user, this is what the function signature looks like. User of returns the user, and user expires returns the expiration date. It does note like some few caveats, right? So I don't basically, for example, if there's no user, any dApp interacting with it can expect that the 0 address will be returned. Same thing with expiration date. So if there's no expiration date or everything, then 0 is returned as well. So things to keep in mind. Again, these are just comments, right? So actually nothing forcing you to do this, but it's expected that you implement it in this way. So the first thing to do and to make sure that we are actually following all of those instructions is just a quick copy paste of this interface. And that's all you need to do here. Wow, so simple. So we're gonna, that's our interface. The next piece then is now we're actually gonna do the ERC 4907. So the way I wanna implement the 4907 is I'm gonna say, number one, it is the interface. So this will allow other people to understand, or I guess bring down those function signatures that signify that it's a ERC 4907. The second piece is because I want to define it as a NFT, I also want to give it the additional property of inheriting the 721 properties as well. So if you guys are familiar, you probably used OpenZeppelin before. If you haven't, let me quickly install this. So OpenZeppelin essentially provides contracts, pre-implemented contracts for various standards that make it super easy to just say something is a 721 or an NFT or whatever. In this specific case, I don't think OpenZeppelin has implemented a rentable NFT standard version of it, which is why we have to do it on our own. But if you are doing something like an NFT or other things, that's just something you can inherently inherit. So to demonstrate that, right, the first thing I said is I want to make sure that this has the properties of the 4907. So that's pretty simple. It's just an is 4907. And then the next piece is I also want it to be an ERC 721. So I prefer to use this specific implementation of the OpenZeppelin NFT. They have multiple versions of it, like with royalties, stuff like that. Let me see if I can, dang it. Okay. That OpenZeppelin / ERC 721 URI storage. Okay, cool. And then the other piece too is I need to import the ERC 4907. And that should be all you need, ERC 721 URI storage. So now we actually need to start implementing everything that's in here. The first piece is actually going to be updating this constructor. I'm just going to go ahead and copy paste because I don't want to type everything out. And after that is going to be actually implementing the 4907, what do you call it, functions. So in order to do things like getting the user, getting the expiration date, we actually need to add some contract variables over there on the contract to store that information. So we're going to store two variables. The first one being a struct. I'm going to call this user info, and it's going to have two pieces of information. So the address, which is going to be the address of user, and then uint 64 expires. So this is the Unix timestamp of the expiration date. And the second piece that we want to use is gonna be a mapping. Yep. Okay, so basically, in order to know, which NFT maps to which user info, this is where we're gonna put that information. So UN256 represents the NFT, what do you call it? Token ID to user info. It's going to be internal. So that means it's within the, I guess, confines of this contract, and then call it users. Cool. And that's the last piece of how we get set up to actually start implementing these functions. So to go through this, we're going to start off actually just by copying pasting over what we expected, right? So the first being set user. So I'm just going to go ahead and copy paste this and change this guy right here. So I'm going to make this public and virtual. If you guys aren't familiar with these function modifiers, public essentially entails that any external contract can call it, right? Virtual actually indicates that any contract that inherits ERC 4907 has the ability to also override it. So if this wasn't here, then it couldn't be overridden. And then next piece basically is actually implementing the instructions here. So the first thing I want to do is actually, because I am free to implement this however I want, what I care about is I want to say nobody can set this user unless you're the approved or owner, in which case the person who is going to be sending or calling set user is going to be message sender. And then token ID is passed through. And comma, and I'm just going to say something like ERC 721, transfer caller is not owner nor approved. Cool. And that is there. And so now let's actually get into the implementation of it. So the first thing we want to do is say storage, I guess, what is the slot that we're going to be implementing, adding this user info to? So token ID. And then filling in that information is going to be user info.expires equals expires. And then, as we said before, updating the user event token ID user expires. And that's it. Next piece then is moving forward. We're just going to keep going through the interface. Here we go. So it's the same idea. So here I'm going to change this to public. It's only going to be returning information, virtual over. Oh, I forgot to add override here. Yeah, so again, here we go. So if first thing we want to do is basically check, if, what does it say? If it has expired, return the 0 address. Otherwise, if there's like no user involved with it either, also return, or sorry, what are the instructions? Sorry, if it has not expired, return the user. Otherwise, if it has expired, return the 0 address. So how do we follow that function or logic? So if, I guess I had just done this guy as UN64. So actually, I need to cast this 256 to users token ID dot expires is greater than equal to get the current time is block type timestamp, and then return users token ID dot user. I do want to explain this quickly because you might be a little confused why I did like 64 versus 256. It's more of like a gas optimization choice, because the way I guess Solidity defines its variables, it's all packed in structs, so it has to be in like 32 bytes. It's kind of abstract, not super important, but that's this here. Did I what's wrong here? Oh, that is, don't be a red squiggle. Okay, cool, awesome. And the last piece is otherwise return the 0 address. In this case specifically, right, if this token ID or this NFT actually never had a user in the first place, Solidity will just default to certain values. So in this case, for an integer value, this will default to 0, which is definitely not going to be greater than the current time. So that's why this logic is here. And then the very last piece is going to be doing our user expires. So let's copy paste that here. Again, making this, oh, whoops. Public view. I'm going to also make it virtual overrides returns. Override. There we go. Did I spell that correctly? Cool. And all it does is return the expiration date. So it's going to be users, which token ID is this, and then expires. And again, as I mentioned before, we don't need to do any special logic because this just will default to 0, which follows the rules. All right, so then the last piece then is going to be two things. So this is actually, we've completed implementing everything in the interface. Now what we care about is I'm going to add 2 extra functions. The first off being a function that supports, it's called supports interface. So in order for other dApps to understand that this contract fulfills the interface contract, there's this other ERC called 165, ERC 165. That's the interface standard. So that's everyone understanding this function called supports interface. I'm just going to go ahead and copy it over since I don't have the interface on hand. But this is the function that it looks like. So again, this would be the function signature as defined by the ERC standard on the EIP page. And essentially here, what this does is it says, does the interface ID match this interface ID? So this is just actually a hash of all of the functions in here. So if it matches this exactly, this is going to be always the same number. Otherwise, also kind of super up. So we also might want to check whether or not it's a ERC 721. That's inherited above here from this guy. And so that's why we can just super. And then the last piece, this is also just a flavoring method. This is not required. I only indicated this to show you how you could kind of modify the 4907 contract for yourself. Is specifically in the Open Zeppelin version of this guy. Is it in here before? No, I guess, is it in here? Before token transfer. They define this method called before token transfer, which basically does certain things before a token is transferred. So what I've decided that I want my interface or my rentable smart contract to have the property is anytime a token is transferred, so anytime it is burned, or it hands over, I guess, what do you call it? User information, or like deletes the user info, or sorry, not deletes the user info, is burned, an NFT is burned. I actually also want to delete the user on that. Again, this is kind of like my personal choice. So like you can think of it as the idea is like if I sold my house to you, I would also kick out the renters in there as well. So that's the logic. So I'm just going to be overriding there before token transfer. And it's going to be a address. This is an address. I believe this is the token ID. And this is batch size, which is going to be UINT 256 as well, I think. And again, it's going to be internal virtual. So this is only going to be called internally. I'm not exposing this to outside contracts. So virtual override. And first thing I'm going to do is do everything that Open Zeppelin says it would do. So from to token ID batch size. And then basically, I also said I want to delete this information. So basically, if from not equals 2, so this is just kind of in case you're not, I guess, transferring it to yourself. That's why that's there. Users token ID dot user is not equal to address. Yeah. Oh, okay. So to re-explain this piece, it's like one piece is like you're not returning it to yourself. It would actually also kind of be a safety measure. So imagine someone had the power to just like also always transfer it from to the same person. They could just burn this token ID maliciously. So that's the purpose of putting in that there. Again, this is my own flavoring, so you don't have to do that. So again, deleting the user. And as we follow the, what do you call it? What do you call it? Follow the interface. We also have to update the user anytime the user or rental information is updated. And so in this case, just deleting this would return this to the default values, which is going to be the 0 address and 0. And so that's all there is to the ERC 4907 contract. That creates a rentable NFT. The last piece then is actually to create our actual NFT collection. So this could be either land, a gaming NFT, whatever you kind of want it to be. You know, it could be something like a subscription as well, maybe. I've thought about different ideas. But anyways, so the last piece now is it's super simple. We just need to import again the 4907 contract. So this is going to be ERC 4907. And it's as simple as saying rentable pets is ERC 4907. And that is all it does. So this is just going to be a very quick implementation of a 721. I'm just going to copy paste here because I don't actually know how many questions I'm going to get. So to quickly, oh, this is wrong. Touch on this, right? Oh, I guess I also need to import at OpenZeppelin counters. There we go. Why is this not file import callback not selected? Oh, haha. Yes, okay, the squiggly line is gone. Cool. So, with 721s, they should all have unique token IDs. So the way we chose to, I guess, ensure it is unique is just a monotonically increasing number as you kind of add more, mint more NFTs. And then in this case, I actually added a public burn function. I mean, this is kind of just like also random. I would actually probably, what do you call it? Protect this by checking whether or not it's approved or owned. I specifically added this here because in my tests, I wanted to make sure that this function that I had overwritten actually worked. So in order to do that, I had to expose burn. But yeah, so that is all of our contracts. We have actually done an implementation. So now all what's left is to actually test it, right? So the first piece is in migrations. Essentially, this is where you give Truffle the instructions on how to, I guess, do everything, right? So I'm going to call it deploy contracts. Yes, you don't have to prefix it with a 1. That is probably just standard practice. If you guys are ever in a place where you're doing like multi-chain development, for example, you're gonna need to pass in different configurations for each migration. And with Truffle, you can basically specify the order in which you want to do it. So the 1 isn't super necessary here, but you might see like a 1, 2, 3, 4 as you like switch between like deploy on Optimism, deploy on Ethereum, make them talk to each other, stuff like that. So it's going to be super simple here. All we're going to be deploying is our rentable pets. What do you call it? Smart contract. So the way you do that is we create this artifact called rentable pets. It's just a contract abstraction that allows us to start interacting with this contract. And so this is the syntax deployer and then deployer.deploy. rentable pets. And that's all there is to the migration. Nice. And so all we need to do now is actually do the migration. Or actually, no, let's write a test basically to make sure everything is working. So rentable pets is in here. This is a really long test because there's actually a lot of functionality. So I'm just going to copy paste this again. Like I said, all of this information and code is already on GitHub. I added this guy right here. So let's just install this. This is also basically test helpers from, or no, OpenZeppelin to help with like expecting reverts, expecting events and stuff like that. As you can see right here, that's how I'm using it. So again, kind of just stepping through the different tests that we have here. The first one is checking that that supports interface one was working correctly. So these interface IDs you can pick up from the interface, the EIP. So as you can see right here, this is going to be the hash of all the functions right here. So when you do that like type of your IERC 4907.interface ID, this is the hash it's going to be returning. And so that's basically how you are checking whether or not it supports interface, making the assertions here. I just want to know I'm writing all these tests in JavaScript. With Truffle, you can write them in TypeScript as well as Solidity. So this is just my personal preference. The second piece is going to be checking all of the require statements. So I'm expecting a revert if we're like setting the owner if incorrect. In order to do that, basically you can fake sending from different accounts. So in this case, like I would modify message.center to be the first account. Oh, I guess to backtrack, basically starting up a local test chain will give you 10 accounts funded with like 1,000 ETH each. So this is how you kind of mock that. You might add like value in here as well to tell the function how much money you want to give it, things like that. And again, same thing, just getting that information, asserting that it's true. Now, this is kind of the bulk of it. I'm not going to step through everything as well, but you can kind of just see that as it should return the correct info. So as we interact with it, either setting the user, making it expired, other things, the correct events are being transmitted, and the correct like user and expiration date is happening as well. So, oh, and as you can see right here, I did want to burn it to see that, you know, things were working. And in order to test this, it's super simple. You just run a truffle test. If I did everything correctly, it should work. So in this specific case, like Truffle test is just going to spin up a Ganache instance within Truffle, deploy your contracts, run the test, and then kill it, right? When you're actually building dApps, there's probably times when you want to persist this information, keep your test instance running so that you don't, I guess, what do you call it? Don't expose or you don't lose information, right? If you want to interact with it like over time and save like the state. So in order to do that, you can also run Ganache in multiple ways. So you can actually run it locally, just like Ganache, and then start interacting with it. So to do that, you would actually have to modify your Truffle config. So you could do this right here. And Truffle will, I guess, default to specifying the network as development. So you could just do a Truffle migrate to do the deployment. And as you can see here, that transaction has happened. Ganache has been running. The other way, so like I said, you could also just do this through the VS Code extension. So if I want to create a new Ganache instance, so let's create a new network. Ganache. So you can choose the difference between fork and local. So I'm just going to choose local. We already are busy on 8545, so I'm just going to choose 9545 and call this, I don't know, 95 VS Code Ganesh. I don't know why I would name that, but okay, I'll just call it VS Code. That's a pretty bad name for it, but that's fine. And then same thing, I'm going to go ahead and start it. At this point, you can start it and you will have your Ganache instance actually in this separate tab. So if you guys have used, I guess, different test chains before, it's kind of bound to the terminal you're in and you have like a lot of problems. Like if I delete this, basically, this will kill my Ganache instance, which is really annoying. But this lives here. So 9545 is still around. And to deploy to this guy, you can actually just do a, go to my contracts here and deploy. So it's this guy here. And all else works. It deployed. And you can also get the details and see kind of a visual view of everything that's going on, which is really cool. And the last piece I want to note is kind of once you're past this entire stage of testing it locally. Oh, I actually forgot to mention even how to start using Ganache if you want to interact with it. Whoops. Okay, cool. Let's backtrack. So I've spun up my Ganache instance on through VS Code. I actually need to go back to my Truffle config right here. My development network is now 9545. Oh, sorry, it actually created it right here. Nice. Okay, so I can just do Truffle console network VS Code. And this will allow me to start interacting with it. If I want to mint an NFT, for example, you might say pets contract equals await. Oh God, why do I not remember this off the top of my head? Okay, deployed. And then now I can do stuff like pets contract mint and then fake URI. And it should have minted it. And again, if you go back to your Ganache instance, you should see that it happened here, as well as in this view. Now we have a new transaction hash to demonstrate that the minting happened. So that's actually interacting with it kind of off the fly. Oh, I guess I've kind of gotten into the next part of hackathon tips and tricks now. So I guess I could go through all of this, but I'll talk through all of them. So another tip and trick would probably be like writing scripts. So you could write what do you call it? A scripts folder, for example. And so continuously doing this mint is kind of annoying. You could write like a script /mint.js, and then basically write like a kind of the same format. So, well, we need the artifacts actually first. And then just, I think, oh God, I feel so pressured to do this correctly off my brain. Okay. And then I guess put in that information here, and then basically all the stuff that you would normally do in a script, like calling the deployed. So like cons rentable pets equals deployed. And you can just do let transaction equals await rentable pets dot mint fake URI, and then something like this. Scripts are really powerful. You can think of it as even creating your own CLI. So if you want to start actually consuming arguments, so for example, like, oh, I want to mint it from like this address versus this address versus this address, you have the power to do so as well. Check out like the Yargs library. That's really good for scripting CLI arguments, stuff like that. Oh, but then I guess at the end, you would just call the I don't know if this is the correct thing, but you get what I'm saying. And then equals main. And hopefully if everything works, I can do the same thing, just truffle exec script /mint.js, and then network is going to be whatever I had said before. I don't remember what it was called. Yeah, okay. Hopefully this works. What is going wrong? I think this is, I wrote something wrong in my script. I'll fix it later. All the code is online, but that's how you would execute it. So anyways, that's just kind of like running through it, all of the things locally. To dive into more test scripts again, I do want to mention Ganache is just hosted on localhost. So regardless if you're using like Hardhat, for example, you can just modify your network configuration to handle that. Other cool things that you can do with Ganache as well, other than forking, is Ganache writes all of the information to disk. So if you guys have been in development before and you're working with your local test chain, you leave your computer and you want to come back tomorrow, for example, none of that information is going to be persisted, right? If you like exit out of your whatever you're working on, right? So I don't have the syntax off the top of my mind, but I think you can do something like create a Ganache DB. And oh, I have the code here, actually. Maybe off the cuff testing. Use Truffle Boxes. You guys can watch all of this. Persist contract. Okay, cool. Nice. And I actually need to make all of these correct. I think this is it. So essentially with Ganache, every time you run it, it's going to create a, what do you call it? Random number of, like, randomly generate the wallet addresses and everything, and the network ID. This is just making sure it's deterministic. But I think if you just do this, it will start this. And then as I interact with this Ganache, it will write that information to disk, and then I can just shut down and always bring it back up with the same stuff. And even if I pick it up next week or whatever, you will always have that same information. And then the last piece I wanted to mention in terms of deployment styles, you can also deploy via dashboard. So this is going to be when you start caring about deploying to your Gurley network or anything. So you can do all of this without ever having to include your, what do you call it? Mnemonic. So in this case, you can switch between the different things. I'm in Gurley, so I'm just going to hit confirm. And confirm, and that should deploy it. Where is my VS Code? I think it's on the same page. Cool. And it'll start deploying. And all the deployments are right here. So I imagine if you go to Rentable Pets and open up the ABI, that's a contract. Is it still deploying? I'm sorry. I mean, Gurley's slow. This is why you don't do it on a testnet. Okay, so if I do this, the network was deployed and you have all of that address information. And I guess the last piece of like what I actually think is going to be the most useful for you guys as you develop is probably like debugging, right? So a lot of you are probably using console log to figure out what's going on. You can use console log with Ganache as well. What I really like is actually our VS Code debugger. So you can debug transactions that happen. Specifically, I've been doing everything on this guy. So I'll be here. But these are the different functions that I've been calling, right? So let's just go to the most recent mint. And it will kind of grab all the information. Hopefully this is working. If not, I can do this also through the CLI. Dang it. Okay, here we go. Cool. And same idea. You can go here, set breakpoints, hit play, have all of the information that you care about, like who's the sender. If you didn't know who like the token URI is, you can just do that. You can step over, go in, like step in, do other things, step out, etc. So this is actually only usable with Truffle right now. If you do want to use this with your Hardhat project, you can do it through the CLI. So that's just going to be like a Truffle debug, and then you would insert your transaction hash in here as well. And you can do this like debugging transactions locally. You can debug transactions on like mainnet. etc., it will pull out the contract information from Sourcify and Etherscan and allow you to kind of see how your contract might be interacting with like pre-deployed contracts by other users. And I think that's probably everything that's like super important. I think the last piece that I was going to say, I had two pieces that I said I was going to handle, right? I didn't explain Truffle Boxes. You guys have been in the, I guess, hackathon for a while, so this isn't going to be as useful for you, but Truffle Boxes is essentially boilerplate code. So there's a whole bunch of them differently. So we have a lot of like layer 2 boxes, which are the newest ones. So getting started with like a Truffle project that helps you with bridging, working with Optimism, etc., starting with an empty React project and how to hook up a smart contract to that is kind of one way you could get started on a hackathon project. The other piece I was going to mention about what's different between what I went over today versus the guide that I'm going to talk about or send you guys is the first piece here in 4907. But for token transfer, when I first created this dApp, OpenZeppelin did not yet have this extra what do you call it, extra parameter. Now it does, so that is something you need to keep in mind. The second piece was I had put ERC 721 here. That was incorrect. I should have put ERC 4907. So just keep that in mind if you're like directly copying pasting from the website. So if you want all that information or keep in contact with me or whatever, this is my, I guess, contact information. Follow me on Twitter, follow Truffle Suite for the latest updates. Unleashed is going to be the series of basically all the dApps I put out. The marketplace or the NFT contract is actually the base for an entire rental marketplace. So moving from that to a rental marketplace to the front end of it, integrating Gelato, for example, for smart contract automation. So automating listing cleanups, things like that. There's a lot of various things. So I have 12 minutes left for questions. I hope that's enough time. Thank you for sticking around as I just barrage you with words. And hopefully we will have some questions to answer. I guess, do I just go for the, I can just read through the chat, right?
Yeah, there's some questions in the chat, but also if anyone wants to just take their mic off or put up their hand, raise their hand using one of the reactions, that's also another way we can go with it. But I guess one question in the chat was the GitHub link to the Truffle examples, if you've got one.
Yes. Okay, let me pull that up. If you want the full guide, which is, I guess, not perfect for that one function, that is here. You can check out basically the rest of the tutorials here. All of this is, I do all of them live streamed as well. So if you want to hear me talk again or just look at my face, you can watch the video. The ERC 4907 one, we actually brought on Jesse, who is the researcher at Double Protocol, who is the ones who, I guess, invented or put forth the proposal. So if you want to hear about it in his own words, feel free to take a look.
Awesome, thanks, Emily.
Yeah.
Another question is, Truffle and Hard Hats, are they friends or opponents?
That's a good question. I like to say we're friends. Actually, if you guys were in Lisbon, I gave a talk about Truffle and I called it First Mover Disadvantage. And a lot of it was, Hard Hat came around and we were really excited for them to come around because they exposed a lot of things that we just had never thought about. And like competition is great for the space. Truffle at one point tried to monetize because we spun out into our own company. But when we spun back into, and that I think made us lose touch with open source products and things like that, and made us realize we really need to work for the devs. And so Hard Hat and Truffle, right? The reason we exist as open source is because we are funded by external companies. In our case, they're Consensus. We're a Consensus. They are funded by Nomic Labs, We actually also invested $1 million into Hardhat as well, just to grow the ecosystem. We're competing for free users. And the other piece is I have mentioned like throughout, like basically a lot of the coolest Truffle features we've actually just opened up to be used by whatever kind of CLI tools are going to be out there, because there's always going to be new ones, right? Foundry's picking up steam. There's Brownie, ApeWorks, etc. Like we build better together, I think is our tagline. And so we do actually work with them, right? So if there's struggles with us on our end being like, oh, we're having trouble like figuring out how to get our debugger to work with Hardhat, their CTO and their team is actually very open to helping us figure out where that friction is happening and how we can change the code to get it working. So yeah, like the baseline, so like starting with like the Truffle config, for example, is going to be what you perceive as the direct competitor part that is not interchangeable. But things like Ganache, things like Dashboard, we're working on debugger, are going to be, I guess, working together. So yeah, friends and
Awesome.
opponents, I guess.
A bit of both.
Yeah.
If anyone has any questions, do feel free to just take yourself off mute and ask out loud. We've got quite a lot of questions that are long coming into the chat. If you just want to read it, Emily.
Yeah, someone asked for my socials. So that's my Twitter. If you want to follow Truffle, that's Truffle Suite. I don't remember what my link. I'll just share my screen again. Hopefully this is big enough, but yeah, there's my LinkedIn. This is just a QR code to like other things. So if you want to email me, yeah. What's the Kim Possible thing? Beep me something if you want to reach me. I don't know. Maybe you guys are either too young or too old to remember that reference, or don't watch Disney Channel. But yeah, those are my socials. I guess to go back, hopefully that was enough time. What other questions are there? So from where I understand, 4907, those dApps that are using the NFT as a verification to provide utility will need to call the function to verify that if this user is a user of the NFT. Yes. So that is going to be assuming that that NFT has implemented the standard, so that they are able to interact with it in that way. So for example, if I was trying to interact with like your NFT, which raises the question, like, what if I already built my NFT to not be like it was before the standard came out, right? The two methods I think of addressing that would be, first part is if it was like a collection that's like an upgradable smart contract, hopefully they'll upgrade it to start adopting the standard. The second piece is going to be, I think Double Protocol actually shows you how to wrap NFTs. So if that collection does want to make their NFTs rentable, they can basically wrap their NFTs with those additional utilities, so that other dApps can interact with them. So like I had mentioned before, ERC is totally up to the ecosystem to implement. So the more people that use 4907, obviously, the more the rentable, I guess, aspect of NFTs will persist. I think one example you might think about is like royalties. So NFT royalties is a standard, but not actually every marketplace doesn't actually respect the royalty standard. So I think like OpenSea, for example, does not automatically understand royalties. You have to set them through their website. So that's completely by choice. So let's say for a portal dApp, we'll need to let the user input what's their rent NFT token ID. Will we need to call the contract to verify? Is that how it can be used? I guess, yes, I hope I answered that question. And because since it's not transferring to the user cannot connect the MetaMask and verify what's their rented. Instead, we need to let them input. Yes and no. So actually, if you look at so I'm assuming you're talking at this point from like the UI perspective. I haven't put up the guide for it. The GitHub is there. The last installment of the series is like the rental marketplace, right? And so it's gonna be, part of it is aggregating all the rentable NFTs that the user has, and then just automatically hitting rent on there, or like allowing other people to rent it out, right? Sorry, okay. We're talking about two different things. Never mind. Because you were asking, how does a user know what their rented ID NFTs are versus how does a owner knows what they can rent out? Yeah, okay, sorry. There's two different streams of thought here. With regards to your question, which is how does a user know what NFTs they have rented? This is actually a problem with, I guess, kind of blockchain development in general. You would actually have to query the history of the blockchain and get every update user event, and then get that information. So if you actually didn't know this, the way marketplaces work for right now, in order to tell, like, I guess, indicate how to sell, what NFTs they have to sell or own, they actually query the blockchain and put all of that in an index. And then what you're actually pinging is an index of the information that was there that will occasionally update. So yeah, that's like a problem. I would imagine, for example, like Infura has an NFT API that allows you to do that aggregation. Companies out there who are putting out NFT APIs, if the rentable standard becomes adopted, might also provide a service that will index all rented NFTs, right? Instead of you having to go through the history of the blockchain and looking up update user or something like that. Where can I find the recordings of previous workshops? I guess, Alex, is that a question for you?
Yeah, I've just answered that. So everyone can find all the recordings in the README forum of the Discord channel. And to join the Discord channel, I'm going to put the link in now. You'll have to go to welcome page and then hack access and click on the Milky Way emoji in order to get access to the Metaverse Discord channel. And from there, you'll see all the recordings from previous workshops, as well as the recording from this workshop will be uploaded tomorrow morning, and you'll be able to access all of that there. Emily, thank you so much for taking the time to chat to us today. It was so great. Everyone really enjoyed it. So thank you so much for everything. And everybody, thank you for coming. If you've got any other questions, send me a message and I'll try to see if I can ask Emily or send Emily a message. She posted all her Twitter in the chat, so you can ask her.
Okay. Good luck, guys. I'm excited to see what you build. I hope the winner uses the rentable NFT.
Awesome. Thank you so much, Emily.
Okay. Bye.
Have a nice day. Bye.